Hello everyone, welcome to the Introduction to Naïve Bayes lecture. Naïve Bayes is a machine learning algorithm that is used in many cases classification problem to carry out prediction on different classes. Naïve Bayes methods, obviously, as I said, they are machine learning algorithms. It actually consists of a set of supervised learning algorithms that are based on the Bayes theorem with a naive assumption of conditional independence between every pair of features given the value of the class variable. So what does that mean? That means naive Bayes mainly consists of using the laws of probabilities to be able to predict some class or some label given a set of features or a set of variable. Take this example, I've put it the formula here. So you do have y, which is the target variable, or the dependent variable, also called class. So when I say classes, I mean in the element or the features you're trying to predict. So think about target variable, dependent variable, or classes. So we use these words interchangeably in the course. X predictors, also independent variable. So what Naïve Bayes want to achieve is to predict the posterior class probability, which is a probability of y given x. Or in other words, what is the probability that the prediction would be y given that the values, given that we know x. So the way to calculate it, you calculate the probability of y. So we will talk about, we will show some examples soon. The probability of y multiplied by the probability of x given y divided by the probability of x. So the probability of y is called prior class probability. The probability of x is called prior predicted probability, and the probability of x given y is called posterior predicted probability. So let's take this example, for example. So we do have y would be whether this fruit is an apple, yes or no, right? So you have two options. It's either an apple, yes, or it's not an apple, no. Now the features or the predictors are also called independent variables. We have x1 and x2. So x1 is a different feature, x2 is a different feature. So x1, the fruit could be round or square. x2, the fruit could be green or red. Right. Now, what does Naïve Bayes do? Naïve Bayes says, okay, in order for me to determine whether it's an apple given some features, x1 and x2, I need first to calculate the probability of y. And the probability of y is given your data set. How many of these are apple in the total? So P, the probability of x would be how many yeses do I have divided by the total of data point, whether it's apple or not, right? And then calculate the probability of x. The probability of x would be calculate the probability that the fruit is round and green. Also the probability that the fruit is square green, round red, square and red. You see? And the probability of x given y would be given that we know that it is an apple. What is the probability that it's round or green, or round or red? You see the train of thought. Right? So Naïve Bayes algorithm implement this calculation automatically in R. So this is the sort of calculation that we will use in our trading strategy, where we say, let's look at the next example to have an idea. So say we want to predict, as we are trying to do now, whether the next candle is going to be bull or bear, right? Let's say we have size, whether the candle is large or small, we have position of the price to the EMA 20, and etc. So we calculate the probability that the candle will be bull or bear given that it's large, given that the price is above the EMA 20, given that the previous candle was bull or bear, right? So this is what Naïve Bayes will do. It says it's a naive assumption. If you go to the next previous slide, it says applying Bayes theorem with a naive assumption of conditional independence. What does that mean? That means that this algorithm assumes there is no relationship between the features or the predictors. Meaning, if the candle is large, for example, there is no relationship whatsoever between the candle being large and the price being above the EMA 20, which is a fair assumption to make, right? So in our example, this could be something really interesting to see, because it looks like there might not be a relationship between the different features. So whether the candle is large has probably nothing to do with the fact that the candle or the price is above the EMA 20 or not, etc. So in the next lecture, we will apply this algorithm in our trading strategy in R. I'll be able to explain further any sort of issues or any sort of analysis. Naïve Bayes also, the Naïve Bayes function in R is able to plot really useful information that in our lecture I will explain a bit. Thank you very much, and I'll see you in the next lecture.